Assalamualaikum and a good day to everyone. My name is Zulaika and I'm here with my colleagues Kelvin, Bimal, Liguyao, Solian and Mai Feng. So today we'll be presenting our research on enhancing software quality in digital marketing by utilizing LSTM models to optimize email campaigns, send times and engagement scores. So this research was conducted at the Faculty of Computer Science and Information Technology, University Putra Malaysia. This is our table of contents for the presentation. It consists of introduction, literature review, methodology, result, discussion and conclusion. So the introduction, this email marketing remains a crucial tool for business to directly and personally communicate with their customers. So the success of these campaigns heavily relies on the timing of email sends. Traditional methods often fails to capture complex user behavior patterns, so it will lead to a suboptimal engagement. So our research will focus on leveraging short-term memory LSTM models to predict optimal send times and improve engagement scores. So the problem statement, this is the slide for the problem statement. The core problem addressed in our research is the difficulty in capturing intricate user behavior patterns with traditional methods. The marketeers needs advanced technique to predict optimal send time and engagement scores accurately. So our goal is to develop an AI model using LSTM to enhance email marketing effectiveness by optimizing send times and improving user engagement. Our research objective including analyzing the relationship between email send times, open rates and engagement scores. So we aim to develop and train an LSTM model capable of predicting optimal send time based on historical email data. We will also evaluate the model's performance and compare it with traditional method. Finally, we will implement a prototype tools that utilize the LSTM model to assist marketers in optimizing their email strategies. So I will pass the literature review to Kelvin.
Thank you, Zulaika. So now we will talk about the digital marketing. Email marketing is a key component of digital marketing strategy. Personalization and segmentation are crucial for the effective campaign. So the Jesuran has highlighted that the personalized email significantly outperform generic one in terms of the open and click-through rates. Timing is also critical, with real-time email achieving higher engagement. How's the AI playing the role in the digital marketing? So the artificial intelligence provide advanced tool for automating tasks, personalizing content, and optimizing marketing strategy. Halim highlight the role of machine learning in enhancing predictive capability. AI can be personalized content based on individual user data, improving targeting and user experience. So to also discuss the advancement in machine learning application in marketing as well. Next. So let's talk about the LSTM models. LSTM models are a type of recurrent neural network designed to capture long-term dependency in the sequential data. They have been successfully applied in various fields such as the sentiment analysis, stock market prediction, and demand forecasting. Razin and Von Hout provide a comprehensive review of LSTM application, highlighting their effectiveness in handling sequential data. So what are the advantages of the LSTM? The LSTM model are known for their ability to handle long-term dependency and complex time series data. Mehta, Saha, and Senapati has demonstrated their effectiveness in sentiment analysis, while Saka and De Bruin highlight their utility in direct marketing analytics. The LSTM model outperform traditional models in terms of accuracy and robustness, making them ideal for predicting temporal pattern. Next. So let's talk about the methodologies. The methodology used in the review study include literature review, empirical research, and performance evaluation. Razin applied LSTM model to business sentimental analysis, while Halim and Duat synthesize findings from numerous studies on AI application in marketing. Saka and De Bruin emphasize the importance of feature engineering in enhancing AI model performance. Next, I will pass to my Matt Lian.
Thank you, Kelvin. So moving on, I will talk about the methodology for our project. The first step in our methodology is data collection. Then we have data processing, AI technique selection, model training, and model evaluation. Next is data collection. Our data set was collected from historical email marketing campaign. It includes information on email send times, open times, and engagement score. The engagement score is a composite metric that reflects user interaction with the email. including action like opening the email, clicking on links, and other relevant behaviors. And here is a sample of our data. This table shows the user engagement with each email. The send time column represents when the email was sent. Open time indicates when the email was opened, and engagement score is a numerical value showing the level of user interaction with the email. From this data, we can observe that email 5 sent on 31st July 2020 at 10:30 a.m. had the highest engagement score of 80 despite being opened on the same day as other emails. So this implies that the timing of sending and the content of email 5 were more effective in engaging the users. And to prepare the data for model training, we performed several pre-processing steps. We converted the send and open time from starting format to date time objects, extracted key features such as send hour, send minute, open hour, and open minute, and normalized the features using min-max scalars. So this made sure that all input features were on a similar scales, which is important for the LSTM model's performance. And next, I would like to pass to Gui Yao to continue with the presentation.
Okay, thank you, Lian. For the AI techniques selection, we choose for the model chosen, we choose LSTM, which is long short-term memory neural network was chosen for its ability to capture long-term dependencies in sequential data. And for the model architecture, for the input layer, it's receive normalized the features basically includes send hours, send minutes, and engagement score. And for the LSTM layers, we choose the 2 layers capture temporal dependencies. And the first one, the first layer returns the sequences, and the second process the entire sequence. And for the distance layer, it's a prediction open hour and open minutes and the engagement score. Also for the truth use, the model architecture defined using the TensorFlow and the Keras libraries. And for the optimization, it's an ADAM optimizer used for the training due to its efficiency in handling sparse gradients. And for the loss functions, it uses mean squared errors implied to evaluate model performance. And for the model training, firstly, the data split, we use a data set divided into the 80% training and 100% testing sets. And for the reshaping data, it includes the data reshaped to 3D format, basically includes simple time steps features, and it's required by the LSTM layer. And for the training configuration, our model configured with ADAM optimizer and MSE loss functions. It's batch size set to the 32 and the epoch to 50. And for the training process, it includes the back propagation through time to update the model weights iteratively until the convergence. And for the model evaluation, first it's an evaluation matrix. It divides the model evaluate using the MSE, MAE, and the Q squared on the testing set. Then it's a prediction process. It's that the model predicts open hour, open minutes, and the engagement score for the testing set. Then it's an inverse transformation. It's predict value transform back to original scale using the min-max scalars inverse transformation. And that one is a performance metric. The MSE provide a measure of the average square difference between the predict and the actual values. And the MAE is indicates the average absolute error, and the R squared is a measure the proportion of the variance steps explained by the model. For the implementation, it includes 3 steps. The first one is a prototype the tool. It's developed use the Python allow marketers to input send hours, send minutes, and the engagement score to receive predictions. Then it's a future development. The tool can further develop into a Streamlit app for user-friendly interface. And then it's a practical application to demonstrate the practical utility of the LSTM model in the optimizing email marketing strategies. Then I'm passed to my partner, Yifeng, to present the result.
Okay, I will talk about the result part. Let's start by looking at the comparison between the actual values and our model's predictions. This table shows how well our LSTM model performed in predicting email open times and engagement scores. As you can see, the model does a decent job predicting the hours, but it's not as accurate for exact minutes and engagement score. And we take a look at prediction errors. This number shows that while the model does well predicting the hour, it still has a lot of room for improvement in predicting exact minutes and engagement scores. That's all for result part.
Yeah, for discussion, our model's performance varied across different metrics. While it accurately predicted open hours, it struggled with minute level and engagement score prediction due to the variability in user behavior. Previous studies, such as those by Lindemann and Araujo, highlight similar challenges. To improve prediction accuracy, we suggest incorporating more granular features, enhancing data quality, and experimenting with different model architectures. For future work, we'll focus on improving data quality by increasing the volume and diversity of the data set. Feature engineering will involve adding new features that capture user behavior and context, such as the day of the week, time of the day, user preferences, and email content. We'll also experiment with hybrid models that combine LSTMs with other neural networks and compare the LSTM model with other machine learning models like random forest and support vector machines. In conclusion, our LSTM model shows potential in optimizing email marketing by predicting open hours and engagement scores. However, further optimization is needed to accurately predict minute level interactions and engagement scores. By focusing on data quality, feature engineering, and model optimization, we can enhance the predictive performance of our model, leading to more effective email marketing strategies and improved user engagement. Thank you. That's all for our presentation today.